much for being with me today. Alistair Morris, you are a senior offshore wind associate at UK consultancy Carbon Trust, and your company has several research projects in the field of clean transportation for the offshore wind energy sector. Please talk us through these projects.
Yeah, so we've got 5 collaborative R&D programs where we work with various international energy companies. The Offshore Wind Accelerator, which is our kind of flagship program, that's split into 5 different work streams, and I manage the logistics and O&M work stream. And in that, we've run a number of different projects that have all been focused around vessel decarbonisation and advancing sort of technology towards that transition towards reducing emissions, basically. So we've just recently completed a project related to offshore charging, so looking to standardise the charging connector, and that's actually available on the Carbon Trust website right now. So it's a high-level sort of design. We've also just completed a project specifically looking at vessel emission metric development for crew transfer vessels, the CTVs, and that's kind of in the kind of infancy because that's still, I think, quite an evolving space. And then we've also got the port charging development project, which is currently in delivery. So that's looking specifically at basically charging infrastructure in ports. But yeah, so I think those are the key projects to highlight.
You mentioned that universal charger that you're developing. Why is it important to have such a universal charger for vessels?
So I think from the OWA's perspective, which is 9 offshore wind developers, they see it that what we don't want to happen is something like what's happened with the automotive sector, where perhaps you've got different manufacturers with different connectors. So this project was driven by the fact that what we're hoping to achieve with it was obviously we undertake this initial work and then we share this with industry, and then industry takes it on and progresses this, and that enables, no matter what solution you're using, whether that be a charging buoy, whether that be a solution from a turbine, that essentially the plug remains the same. And it means that doesn't matter what vessel you're using or solution, it at least means that you have that consistency. So yeah.
And that's being picked up by lots of manufacturers in the market, or?
Yeah, well, I suppose I'm trying to drill up support for that right now. But yeah, I think we see it as obviously the 9 offshore wind developers that we work with in OWA represent around 75% of the installed capacity in Northern Europe. So we kind of feel that from our perspective that we've put this out there, and we'd really like to work with those interested to take this forward and develop it, basically.
You're also involved in a retrofitting project that's to do with the electric vessels, right? Tell us more about that.
Yes. So the Offshore Wind Accelerator, although this hasn't been funded directly by ourselves, we've been involved with an Innovate UK supported project, which essentially is looking to retrofit an old CTV, a 20-meter CTV, to electric batteries. So essentially remove her diesel power units and replace those with electric batteries. And the purpose of that is obviously we're going to have so many old vessels in the market still, even when we do move to newer low emission vessels. We need to have some kind of strategy to kind of deal with those. And this is, I suppose, a first step in that direction of understanding what's possible and seeing if we can retrofit an old vessel to modernise it.
So we will soon see lots of electric vessels in the market, or are there still major hurdles to that, do you think?
I think I'd like to say hopefully very soon, but I guess at the minute the hurdle is probably the range, a little bit like the car analogy. But I certainly would say for close to sort of nearshore sites, that's a real achievable goal there. And vessels, I'd hope to see electric vessels in the not too distant future servicing those nearshore sites that we have all over Europe. I'm not sure electric's going to be the primary fuel for far offshore sites, but yeah, hopefully it's the low-hanging fruit.
Thank you very much, Alistair. Robbert van Rijk, you're founder and managing director at Windcat Workboats with its joint venture TSM Windcat in France. Your company designs, builds and operates boats. How does that help you reduce these boats' footprint?
Well, perhaps it's good to start with the way we design boats. Because the first start by...
Exactly.
Am I flicking or somebody else flicking?
You are.
Okay, thank you very much. Welcome. So it all depends. It starts with the design of not consuming fuel. We can build big boats, we can build boats with a lot of power, but you also can build intelligent boats. And then it depends where you're going to use it for. Is it shallow draft? Then you do water jet. When it's deeper waters, don't do water jet, because a water jet is normally consuming 15% more fuel. So don't choose that solution. Then it comes to hull shape, and then it comes to a cleaner energy. And I agree with my neighbor, electric will be one part. All fuels, all renewable fuels are good. Methanol, synthetic fuels, but we have chosen a route for hydrogen. This is us, Windcat Workboats, with France and a joint venture with TSM, already an established joint venture which we work for the last 35 years. So fully France, French crew, French local content, and then in Germany we have a similar joint venture. But what do? We combine diesel with hydrogen. We do this in an internal combustion engine. What is an internal combustion engine and how do we do it? I'll probably come back to this picture later on. But this is actually where we are today. Is there a pointer?
No, I don't think so. Oh, it's there.
No. There's no pointer, but I can explain it a little bit. Emission reduction is on the vertical line, horizontal line is where we are in time. We believe that a dual fuel ICE engine, ICE stands for internal combustion engine, is a way to go forward for the time being, and it is a transition type of propulsion pack. Then we come to internal combustion engine or monofuel, and the last part probably will be the future fuel cells. Today, a fuel cell of 300 kilowatt is nice, it has the shape of this table, but the air and water treatment system is a 20-foot container. So that does not fit on a CTV. So therefore we have chosen for the internal combustion engine. And what do we do there? It's pretty easy. On the inlet stroke we aspire hydrogen. Then we get the compression stroke. There we measure how much more diesel we can put into it. Then we use diesel as a piloting fuel, and then you get your stroke. And the exhaust is the result, which is approximately today a 50% reduction in CO2. And this is how we do it. In the front you see the orange line, that's the bunker station. We are doing it with compressed hydrogen, so it's 3 storages, total of 2 hydrogen you measure in kilos, not in liters. We have 200 kilos of hydrogen, which is approximately the equivalent of roughly 600, 700 liters of diesel. That's what we mix in a 50% division, and the other part is diesel. So the orange line is high pressure, 350 bar. The green line is just when we get an incident, we blow off. And then you have the blue line, which are low pressure, goes into the engine room with a double walled pipe. Here you see the storages from the backside. It's new. We are piloting actually. And what you see here, this is in the engine room. So you see the wired pipe, which is a double walled pipe. Then the blue box, that's where we mix hydrogen with diesel. There's a lot of systems, safety systems, architectural wise, and we measure a lot. That's what the industry wants, that's what we want, safety first. So here you see all kinds of sensors to detect in case we would have a problem. But it's a 3-layer safety system. Bunkering, when there's no hydrogen, so it's the chicken and the egg story. When there's no hydrogen available, there's no consumer. And when there's no consumer, there's no hydrogen producer. So we produce our own hydrogen and we transport our own hydrogen with our troop trailer. This is not a render, this is reality. This is in Amuiden, together with CMP Tech, our shareholder. This is the bunker station, high pressure. And this is the future. We believe that, again, we are living in a transition world. And a lot of people talking about zero emission. But in my belief, zero emission does not exist. I think it's the English wording is perpetual mobile. Is that English? So the non-energy resisting movement does not exist, so zero emission does not exist. For your electricity, you need a lot of power to create electricity. For hydrogen, we need power to create hydrogen. So, but let's start. Let's start innovating projects. This is an innovative project. We are innovative projects. And hopefully the industry sees that and is willing. We do not need subsidies. We need a customer who is willing to pay.
And you have a system that's called Wind Grip System, right? Tell us a bit more about that.
Oh, we have to go back a few pictures. Yeah, I would like to pinpoint it here, but you can't see it. But in the front, to make it an additional safety system,
yeah.
Probably when we go back here, there are 2 winches in the front where we sling ourselves on the boat landing. Hydraulically we grip, so we do not push anymore, so we don't need pushing power, we don't consume fuel. It's just a small generator which we are using.
To link your boat to the turbine.
Actually, we hook ourselves a little bit to the boat landing.
Okay.
Yeah, and this is the newest model we are building. It's a CSOV. The CSOV is also based on dual fuel, partly hydrogen. The blue containers are 400 kilos of hydrogen on the stern. And we can supply ourselves with the new model MK5 Hydrocat.
Okay.
That's a little bit it.
Thank you.
Thank you.
Thank you. Thank you both. Thanks for joining me on this panel. And thank you for listening, everybody.
Thank you.
Thank you.